Welcome back, learners. So now jumping to our second concept, whereby now we will be looking at the forces that are working in pairs and also looking at the balanced and the unbalanced forces. So we are saying that forces are always working in pairs. So when two objects, that is now object A and object B, interact, they exert a force on each other, so each of them will exert a force onto each other, and those forces are saying that those forces are always acting in pairs. Say for instance, you are pushing a wall. Did you know that the wall is actually pushing you back? So now we're saying for every action, there's an equal but opposite reaction. That is, if you are applying a force onto the wall, that's you putting in action. Now the wall will exert the very same force onto you, but in an opposite direction. That's now the reaction part from the wall. So you being object A, you are exerting a force onto the wall, and then the wall will exert the very same force back to you, but in an opposite direction. So we're saying that the force that object A exerts on object B is equal in size. So whatever force that you're exerting onto the wall will exert the very same amount of force back to you, but in an opposite direction. So we're saying that force is equal in size, and then the direction, however, it is different. If we apply a force of 5 newtons to the wall will apply the very same 5 Newton force back to you, but in an opposite direction. Equal forces exerted on the same object, they are going to be balancing each other out. Now remember, when forces are balancing each other out, they are said to be at equilibrium. However, should the forces not balance each other out, then they are not going to be said to be at equilibrium. So the forces that are exerted on different objects cannot balance each other. So if I apply a force onto the wall, and you also apply a force, let's say now I'm applying a 5 Newton force onto the wall, and then also turn and apply a 5 Newton force onto a block of a certain mass. Now these two forces, because they are applied on two different objects, even though they are the same, because they are applied on two different objects, we can't say that those two forces are going to balance each other out. Forces only balance each other out if they're exerted on the very same object. Now then, if that's the case, then we can say those forces, after they've balanced each other out, they are at equilibrium. Should they not be exerted to the same object, they can't balance each other out. So, if more than one force is exerted on an object, the forces are going to combine to deliver something called a net or a resultant force. So we can either say when we have more than one force acting on an object, those forces that are acted or that are exerted on an object, we're going to be adding them together to give us something called the net force, or sometimes referred to as a resultant force. Now what do we mean by that? On this picture that we have here, there's a force of 18 newtons that is exerted onto the book into a certain direction to the right. And then there's also another force exerted onto the very same book. But then notice that these two forces exerted, they are not the same. So we can't say that these two forces are going to balance each other out. They're only going to balance each other out if the size of the two forces are equal. If this was 18 and this was 18, then those two forces would say to be balancing each other out. So when we're adding these two forces, when we're adding the 18 plus the negative 2, the answer that you're going to get is going to be negative 20. So the answer that you're going to be getting is going to be a negative 2. So this is negative 20. The answer that you're going to be getting is going to be a negative 2. Remember, the unit for force is Newton. So it's going to be a negative 2 Newton. Because we are not getting 0 as our final answer, these two forces are not balancing each other out because they are not of equal size. So as we have said, the combined effect that they have on each other or that they have on the objects depend on the size and direction of each force. Because this force F1 is greater than F2, that means the direction in which this book is going to take will depend on the bigger force. So the bigger force always determines the direction in which that object will take. If the bigger force was on F2, that would mean that this book will be going towards the right-hand side, towards the direction of F2. But in this case, because the bigger force between 18 and 20, it is with regards to, it is going to the left, therefore the book is going to be going to the left-hand side. Now the negative that we have shows direction. Now that is to say, right is positive and left is negative. And if our answer is negative, that means the direction that you're taking is the one that is going to the negative side, that is to the left. Now, examples of forces that are balanced or forces that are in equilibrium. So if a boy pulls a crate across the floor with a pull force that is equal to the frictional force of the floor on the crate. So a boy pulls a crate across the floor and there's a frictional force, and that frictional force is equal to the pull force. So these two forces, they are equal, as they are saying. So the force going to the right and the force going to the left are equal. Remember, equal magnitude of forces balance each other out. So in that case, those two forces are going to be at equilibrium. Should one of these two forces be greater than the other, should the pull force be greater than the frictional force, then those two forces will not be balancing each other out. Now the second example is the weight of a wooden block that rests or moves on top of a floor, which is the surface, is equals to the push or the Fn on the floor onto the block. That is now to say, should we have a surface and we also have a wooden block, this wooden block is resting on this surface. This wooden block is applying a force onto the surface. That force is going down. But then remember, for every action, there's an equal but opposite reaction. That then means the surface is applying the very same force onto the block, but then in opposite direction, going up. Now, because this object is resting or not moving, and we are saying that the two forces that are applied by the surface and the block are equal, then the forces are going to be at equilibrium, or the forces are going to be balancing each other out. So if the forces exerted on an object balance each other, the object will remain stationary, or the object will keep moving in a straight line at constant speed, and also that object will keep its shape. If the objects or if the forces are of equal magnitude, the object that is in question there will either remain stationary. If the object was moving, that object will continue moving in the same constant speed, and then that object will not change its shape. That object will not be deformed, because all of the forces that are acting on it, they are going to be equal and they're going to be balancing each other out. Now, when the two forces are not in equilibrium, what then happens? So let's now say one team in a tug-of-war competition exerts a larger pull force on the rope than the other. So we have two teams, Team A and Team B. Team A exerts a larger force onto the other team, whereas Team B exerts a smaller force onto the other one. Now remember, we said forces only balance each other out if they are equal in magnitude. In this case, Team A exerts a larger pull force, whereas Team B will exert a smaller pull force. So therefore, in this case, the two forces are not at equilibrium and the two forces are not going to be balancing each other out. Now the next example would be a boy pulls a crate across the floor with a pull force that is larger than the frictional force on the floor onto the crate. So in this case, on the previous example, the pull force was equal to the frictional force. In this case, the pull force is larger than the frictional force. Now, should the two forces, as we have said, should the two forces not be equal in magnitude, then the two forces that are acting on this object, they are not going to be balancing each other out. And if they're not balancing each other out, they are not going to be said to be at equilibrium. They are not in equilibrium. Now, the weight on an object hanging from a rope a moment before the rope breaks is larger than the tension force in the rope. So there's an object that is hanging on the rope, and then this object or this rope breaks and the object falls. Now that means the force going down is much greater than the force going up. So in this case, that's the reason why the object fell, and the shape of this combination of the rope and object system, it changed. So if the rope breaks and the object falls to the ground, that then means the force going down is greater than the force going up. And in that case, those two forces are not in equilibrium, and those two forces are not going to be balanced forces. So, in conclusion with this, we need to say that an unbalanced force exerted on an object can change the object's speed, direction, and shape. If we have unbalanced forces, and those unbalanced forces are exerted on an object, the speed, the direction, and the shape of that object is going to change. But should the forces be balanced, then the speed, the direction, and the shape of the object is going to remain the same. Now, with that said, I hope you learned as much information as I did, and you had as much fun as I did. Until I see you next time. Bye.